So can you please inform us about the dates of exam?
Yes, dates of exam will be this week, starting today, the new week, and the week after during the class time. So we have 8 hours, and 8 hours we shall complete the Viva during the regular class hours of Wednesday, Thursday, Friday. The week starting today,
And
7th.
and the
So
schedule will be.
you will have exam on 10th, 11th, 12th of November, and then you will have, wait a minute, is there a holiday there? Guru Nanak birth, I don't know which day institute holiday. So there will be 17th, 18th and 19th. I do not know whether there is a holiday or not. If so, then that 2 hours we will do it at a mutually convenient time. Argodeep, Argodeep,
Yes, sir. 19th is a institute holiday, sir. Friday. That Friday.
reschedule the 19th, talk to the students because we will do from the end of the roll list this time. We'll
Hello.
start. We shall start the Viva with the students towards the bottom of the roll list. We started the first
Okay,
Viva
sir.
from the top of the roll list. We will start the Viva from the bottom of the roll list. So the students on
Okay.
the top of the roll list for 2 hours, they will be rescheduled some other day since 19th is a holiday.
Okay, sir. Okay.
Okay, we'll find out a way so that
Sir,
it, yes.
sir, will it be scheduled on next week only, or it can be scheduled later?
No, before then.
Okay, okay, sir. Okay.
Okay, because we have to upload the grade on 20th November.
Yes, sir. Okay, okay.
Okay, we have to upload the grade.
Okay, okay.
We shall do the needful. We will find a way to take care of the students.
Yes, yes.
Today will be the last class, and they will have plenty of time. How many have joined so far? 39, right?
Yes, sir.
Yes, sir.
Gauri, are you there?
Yes, sir. Yes, sir.
Please, you guys work with Orgodip and find an alternative date for 19th. What I request all of you is this. If you need any help for the preparation, today I will finish the regular semester teaching. So if you need any clarification, help, explanation, I'll be more than happy to meet you on any day because there will be no more class and I don't have any important meeting scheduled except HODs and Dean's Committee meeting. I don't know when that will be, I forgot. Other than that, I'm available. I will be able to have a discussion whenever you guys wish, if you have any questions or doubts.
Sir, if you have increased the time for one group, like last time it was 15 minutes only, so it is
20 minutes. It will be
sorry.
20 minutes. But you see one thing, just for that minutes you count. In writing, if you have a written test, how long will it take to answer? Okay. You think
Yes.
that Viva, it thinks that you have very short time, but you can answer. And when I see the answer in the right track, I say, okay, thank you. I know you know the answer and I stop because I got the message loud and clear that you know the answer. That's all. So if you need extra time, you let me know. I'll be more than happy to provide time for you.
So per day, how many
I
students will
hope,
be?
I hope at the end of the semester you have realized that I am not to find fault with you. Okay. If you
Yes.
get all of you get excellent grade, nothing can make you make me more proud or happier than that. I want all of you to get excellent grades. Okay. So never consider this exam is kind of a trick to give you lower marks or anything. No way. It will be other way around. And only fundamental questions will be asked, no tricky question. Who was asking question?
Sir, I was asking like how many students will be giving the Viva per day?
Oh, that Argodeep will tell you.
Acha. Okay,
Ah,
sir.
It will be around 10 to 12 students.
three
So
groups.
we will get a list like we got in midsem.
Huh?
Will we get a list like we got in midsem, like which
Oh, yes,
all
yes.
days we have?
Yes, you will
Okay.
get it. There will be a list. But I request all of you not to miss the exam, okay? God forbid, if you are not well enough to take the exam, or they are in an emergency situation, please inform me. But final exam cannot be rescheduled, but for you, I'll try to accommodate it if it is a very, very genuine concern, a genuine reason. If you do not have power or there is a power cut takes place during exam, if it is a genuine thing, I'll always accommodate you. But please do not intentionally do so. And Arghodi, please tell the student that 2 students did not take the previous Viva. We have to take those makeup Viva, otherwise their grade will be very poor.
Yes, sir. I will post a message in the Teams so
Okay.
they can be informed from there.
They can reschedule that exam with us this week. Okay. Because we reminded
Okay.
so many times, but they are not responding.
Yes, sir.
Any other question you have? Anybody? Okay. So today what I will tell you, few things you need to read on your own. So do you have the Callister textbook next to you? Any chance? How many of you have? Hello? Are you there?
No.
Are you there? Present?
Yes, sir. Yes, sir.
I use the Callister's International Edition 9th edition, but the Indian edition, the paperback one, is based on the 7th edition, close to it, 6th and 7th combination. So original US edition, 7th edition, I opened it up, not the 9th edition. And I will tell you the chapter name and pages from the 7th edition. It may or may not match with your Indian book, Indian reprint, but the section head will be there. And very simple thing, I will explain to you to read it. In my 7th edition, Callister's book, the chapter 12 is on structure and properties of ceramics. Structures and properties of ceramics. The structure, crystal structure, it has already been covered in great details beforehand. So you don't need to learn anything new, like cesium chloride structure, zinc blende structure, few other allotropic forms. You have learned in great details. So just you can glimpse through that few pages. It will not take few minutes to go through it. Then comes silicate ceramics, because among ceramics, silicate ceramics is very important. The silicate SiO4 4- tetrahedron I mentioned, and how these tetrahedron are assigned to the lattice points to build the structure. There is nothing new here. And silica glasses, the most important constituent of glass is silica or silicate glasses. That you quickly go through that thing, because already it has been taught. You do not have to study that much. We also talked about diamond, graphite, and fullerenes, microstructure, crystal structure before. These three are important: diamond, graphite, and fullerenes. Just glimpse through that thing, okay? Then imperfection in ceramics, atomic level defects. We talked about dislocation, point defects, all this. in details for crystalline materials. Similarly, crystalline ceramics can be amorphous as well as crystalline. In crystalline ceramics, you can find out the Schottky defects that you know. Just spend few minutes on that. Nothing more, impurities in ceramics. But concentrate on some ceramic phase diagrams. This is important. I have taught the phase diagram in great details. And with that knowledge, you can understand any phase diagram. There are specific 3 or 4 phase diagrams in ceramics I shall mention. You can take a look at it. One phase diagram between Al2O3 and Cr2O3. We studied the phase diagram, say isomorphous system between nickel and copper, and I showed between element A and element B hypothetically. So in case of element A, I put Al2O3, and for element B, I put Cr2O3. They form an isomorphous system. You see, alumina as a constituents and chromia as a constituent, they are forming solid solution for entire composition range between 2 oxides. And in molten state, they also form one liquid solution. So it's an isomorphous system. Just take a look at this phase diagram. It will take a couple of minutes to understand that because you know that thing. Just a couple of minutes you spend. Okay. Hello?
Sir, are you present? Are you showing any slide?
No, I'm not showing any slides. You will
Okay.
find out in the book. Just take a look at it.
Okay.
Okay. Take another look at a phase diagram, MgO and Al2O3. You see in metals and alloys, we had between elements. For ceramics, it's between compounds. So MgO and Al2O3. It is an interesting phase diagram because it has 2 eutectics, hypothetical. And it has a compound called spinel, S-P-I-N-E-L. Trust me, you do not have to learn anything new. Just these are certain common phase diagram in ceramics. Just glimpse through that thing. How you can apply your knowledge of phase diagram of metallic system to ceramic system. Then another phase diagram of interest, listen carefully. ZrO2 and calcia, especially ZrO2 and calcia, calcium zirconate, etc. For calcia, you let us see ZrO2 and calcia. In late 60s, early 70s, people started doing research on engineering ceramics. Before that, ceramics were meant for glasses and refractory linings for furnaces, high temperature resistance coating. But ceramics have very high compressive strength, just like cement. You increase its tensile strength by reinforcing with steel. But ceramics are inherently brittle. So the research on quote-unquote engineering ceramics started in late 60s, early 70s. Zirconia has a polymorph. Allotropy we call for elements, for compounds we call polymorphism. So it has 3 polymorphs, zirconia. Room temperature to 1150 degrees Celsius is monoclinic zirconia. 1150 up, it is cubic, and then from certain temperature, a tetragonal, sorry, 1150 upwards is tetragonal and is close to, I forgot exactly, 2350 or so. Just let me take a look at it. I'm forgetting that thing. Just give me a minute. I forgot. You see, from room temperature to 1150, zirconia has the crystal structure monoclinic. 1150, and I forgot, it is approximately 2400, if I am correct. Just check that yourself. It has a tetragonal structure. And that from that temperature up to its melting point, it has a cubic structure. So 3 polymers of zirconia, from high temperature cubic, then tetragonal, and then monoclinic. And tetragonal to monoclinic, this polymorphic transformation takes place at 1150 degrees Celsius. And that is accompanied by a huge volume change. and that initiates cracks in the system, cracks. So people started adding other ceramic compounds to this zirconia to see whether I can resist the formation of crack. So they started adding calcium oxide, CaO, and that is stabilizing high temperature crystallographic form of zirconia, especially cubic or tetragonal. It is stabilizing those crystal structure rather than monoclinic, preventing this cubic, a tetragonal to monoclinic phase transformation. So they are partially stabilizing this high temperature crystallographic structure. Hence it is called partially stabilized zirconia. Partially stabilized zirconia. Later on it was found that you can add other compounds like yttria instead of calcium oxide to get partially stabilized zirconia. People use magnesia also. And that zirconia has a very good strength. And hence that is the birth of the true engineering ceramics. So this phase diagram, you please look at it, zirconia and calcia. This is important. And you see cubic zirconia, the American diamonds they called, it is basically the cubic form of zirconia. And that is a people use for jewelries. It looks like diamond and it's called American diamond or cubic zirconia. Any question? Anybody has any question? And next important, and this is simple phase diagram. You can easily figure it out on your own because you understand the phase diagram. And there are two more ceramic systems of importance. One is silica, SiO2 and Al2O3. Please look at the phase diagram of silica and Al2O3. It has an eutectic, and you find out in silica refractory, if you by mistake add a little bit of alumina, it forms an eutectic reaction, and that lowers the melting point of silica. There is no solubility of alumina in silica or silica in alumina. There is no terminal solid solution. Only silica exists in one end, the other end alumina exists. But if you add a little bit of impurity in silica, its melting point falls drastically because it forms an eutectic. So alumina is an impurity in silica. These are the phase diagrams you need to look at it, nothing more than that. And the next chapter 13, application and processing of ceramics. You see a table in 13.2 given classification of ceramic materials on the basis of applications. Ceramics are classified into several groups: glasses, clay products, refractories, abrasives, cements, and advanced ceramics like engineered ceramics. Glasses for regular glass we use from window pane to car windshield to tumblers for drinking goblets, all those things are glasses. Glass ceramics means the amorphous glass by heat treatment made crystalline. I showed you those product that half frozen and half portion is in the flame and is not cracking. Dow Corning started making these ceramic crystalline glasses, which has a very good strength. Clay products, various dinnerwares and etc. are made out of clay products. Refractories for furnaces. Abrasives like emery papers and all those papers, abrasive papers, they have abrasives connected to it. Various drill bits have abrasives connected to coated on that. Cement is also a ceramic, and advanced ceramics like partially stabilized zirconia and so on. That's all you need to know. This is all about ceramics. Any question? Then we'll talk about what you need to know about polymers. Any question on ceramics? Hello?
No, sir, as of now.
Anybody has any question? Now move to chapter 14, polymer structure. What is a polymer? Numerous MER units are added together and that makes a polymer. So that is polymer like C2H4. But if you have acetylene, C2H2. A simple thing from your organic chemistry class, you know that. What is a polymer molecule? Nothing more than that to read about this. But you know from your school days how to calculate the molecular weight. But this terminology, please remember this. Molecular structure of polymers, chapter 14.7. It is classified into 4 different structures of polymer. 4 different structures of polymer. One is called linear polymer. The simple chain of several Mar units is called linear polymer. Okay, linear polymer. If this linear polymer have branches, it is called branched polymers. Branched polymers. If these branches are joined by, if these linear polymers are joined to each other by these branches, then it is called cross-linked polymer. Cross-linked polymer. When you heard of vulcanization of natural rubber, so basically you cross-link these chain polymers to have this vulcanized rubber, okay, to have much higher strength. And the 4th group of polymer is network polymers. It forms hexagonal type networks and it's called network polymers. So these 4 terminologies of polymers, just one page, you need to take a look at it. And there is 14.10, it is called copolymer. Copolymer means we have the same Mar units are joined together, but if you have different types of Mar units are joined together, then it is called copolymer. But not one type of Mar, but 2 different types of Mars units are joined together, it is called copolymer. Copolymer. That's all. That's it. That's it for ceramics and polymers. And just for your viva and other purposes, not for my class only, but your job and others, you get hold of a small book, Physical Metallurgy Principles and Practice. Physical Metallurgy Principle and Practice by Professor V. Raghavan, retired professor of IIT Delhi, 3rd edition. This book is like a notebook, a quick glimpse through it. It's a small book. It doesn't explain the principles in details, but it is a good book to read before the viva for job interview and other things, training placements, all those things. You need to have a look at it. The small book, it costs, I forgot, 200-300 rupees, but it's good for interview purposes. And towards the end of that book, there is a chapter on engineering metals and alloys. If you get time, please read that book. It will explain to you the difference between steel and cast iron microstructure, what are different types of cast irons, what are different types of high temperature alloys, what is a stainless steel. There are 3 types of stainless steel principally, austenitic, ferritic and martensitic. Yes, please. Any question? Hello? So different types of common engineering alloys people use, high-speed steel for machining purpose. It has small friction, tiny friction. It talks about carbon steel, high carbon steel. What do they mean by that? Switch off your microphone. So for this week's Viva, solidification, phase diagram, heat treatment of steel is very important. And your edge hardening, of course, included. So basically, after mid-sem, whatever taught from solidification onwards, we will ask in details questions. So these three major chapters are there. Please read very carefully for the exam. Majority of the, and whatever I said about polymer and ceramics, quickly go through it, very quickly. Trust me, it will not take more than half an hour to understand the ceramics and polymers I mentioned today, because already you have the background knowledge. And for these various metals and alloys, I said from Raghavan's book end, please get hold of that book and read that thing. It is required for various vivas. And there is nothing I need to explain it, because the principle behind designing of all these alloys and steels are already covered in my class. So I do not want to waste your time by having classes and showing few slides, and all the principles are already known to you. That's it for the regular semester classes. I'll be more than happy to explain anything you have in your mind.
So just one small request, if you can please share the slides for the revision.
All slides are uploaded. All my slides are uploaded. It's shared. Orgodev, I saved all slides. I did not miss a single slide.
Yes, sir. All video lectures are there.
All video lectures are there. All video lectures are there. And in the lecture slides, video lecture, all references are given. I did not take from any exotic places those slides. These are all from the textbooks. Okay.
Yes, sir.
Every class is uploaded. Anybody has any question? Orgodev? Orgodev?
Yes, sir.
Please finish the Viva of the BTech students first.
Okay.
The roll list of BTech students from the end. And there are 3-4 students, BTech students, who are taking the class later on with different roll numbers. Include them. So them, all BTech students, Viva, let it get it over. And then we'll have the postgraduate students, MTech and PhD students, Viva. Because BTech have a large number of exams. So let them cover, and it will be easier to accommodate MTech and PhD scholars on alternate timing if we cannot find suitable timing because of the Guru Nanak birthday. Okay.
Yes, sir. I will do.
Okay. You guys have any more question? Or during Viva, please keep a notebook and paper and pencil. If you have to draw certain diagrams, you can quickly draw and show me. Okay.
Okay, sir.
Okay, sir.
Please keep it open. So because phase diagrams are another things I am teaching, I asked draw it quickly and then show me a microstructure at the temperature. Please keep it handy. A notebook and a pencil. Any question?